Hi everyone, my name is Anvita Bansal and we are back with another lecture based on today we are going to start with stacks and queues. So I'll just quickly show you the problem statement so that you guys can have a look. So the problem that we are discussing today will be merge overlapping intervals, and this is a section from your SD sheet which we'll be starting off with today. Okay, so I'll just quickly check if I'm live. I think we are live. Let's have a look. Just a moment, guys. I'll just wait for a minute for you guys to join and then we will start it. Meanwhile, just check with I'm just looking out if my network becomes okay. Okay, let's start off. Actually, I'm not willing to start on this bad network, so just give me 1 minute. Give me a moment, guys. I'll be back. Let's start it. I'm sorry for the delay. Let me just check. Okay, fine. So I'll just explain you the question quickly. Let's have a look. I just wish the network gets better. Okay, fine. So what does this problem say? I want you all to pay very good attention at this problem. This is a very nice problem. Secondly, a lot of things will get clear via this problem, not just concept of stack. Okay, fine. So given a collection of intervals, yeah, the task is to merge all of the overlapping intervals. So what do you mean by this? See, there is an array, 2D array has been given. So each of these can be considered as arrays of two elements, which denotes start and end time of any particular interval, right? Okay, so if I check, I have interval 1, 3, then 2, 4, 6, 8 and 9, 10. Do you see overlapping intervals? If you find such overlapping intervals, you should merge them and return them as one interval. Now, how can we do this problem? I'll just take an example, the same test case, and show you on the blackboard. Okay. Fine. Okay, so let's have a look. So the given test case is you have intervals like this 1, 3. I'm writing it here one by one. Okay, I'm just converting that 2D array like this. I have just split it so that you can understand. This is interval 2, 4. Then we have interval 6, 8. Then we have interval 9, 10. Right? Okay, I think these are the intervals we have. Now what do we want to see? See, if you check interval 1, 3. Let me write it here. This is 1. This is 3. Okay. Next is the interval which is starting at 2. This interval is starting at 2 and ending at 4. Okay, so can you easily observe this thing that 1, 3 was one interval, 2, 4 was one interval, and you can see that 2 was lying between the interval 1 and 3. So I can merge this interval as 1 to 4. This is just one observation out of two intervals that we got, right? This is just one observation. Moving ahead, now I have one interval which starts at 6 and ends at 8. Okay, so there is this another interval. Can it be merged with the previous intervals? Not yet, not as of now. The reason is, so far I have 1 to 4 as my interval, which I have merged out of these two, right? And why did I merge? Because I found that there was an interval starting at 2 and ending at 4. So this 2 was lying between the interval which was starting at 2. It was somehow lying between the interval of 1 and 3. So I easily merged it. Okay, now the next interval that I have in my row is 6 to 8. So 6 is start and 8 is end. I see that 6 and 8 do not collide with any of the previous intervals, right? It's altogether a new interval, so it cannot be merged as of now. What is my next interval? It is 9 to 10. So you can see that 9 and 10, the interval which starts at 9 and ends at 10, is also a different interval which is not colliding with any other interval that has been previously found, right? So finally what do I have is, I can say that I have 1 to 4, fine, then I have 6 to 8, then I have 9 to 10, and this is what you can see in your answer as well. If you check the answer for this question, you will see that you have to return output as 1, 4, 6, 8 and 9, 10. So these are the intervals you found out after merging. Okay, so I will now explain to you how can we solve this problem using stacks. Let's have a look. First thing is, see, we have all in greedy approach, we have solved questions of minimum platforms, right? So at least if you have done problems of greedy and activity selection problem, then we have done those min platform problem. So I expect that at least so far you must have got an intuition of how we can solve this optimally. What different can I do is, means different for this question but similar to what we have done previously in that, using that greedy approach, was that why not I sort my intervals on the basis of their starting intervals. How is this thing going to help me? See, by default, for this test case, I already got the starting points of the intervals in increasing sorted order, right? This is an increasing order itself. So I did not have to worry about, let's say I do one addition in this problem. Let me write, let me think. Okay, so let's say there is an interval with 3 and what shall I write, 9. Now what? Now you have intervals like these. Now you have 3 which lies here, you have 9 which lies here. So you can clearly see that 3 and 9 are actually overlapping 2 of my already existing intervals. Why? 3 is lying between this and 9 is actually lying till here. So if I merge this starting point in this interval and I merge 9 with this interval, what can I get? See, this will be collapsed and it will actually become part of 3 to 9. And since I already have 9, an interval starting at 9, so 9 can be means 9 can be taken off and my end can become 10. And this 3 lies in this, so my overall interval actually becomes 1 to 10. Okay, so now my question to you is, why did I introduce this interval and what I wanted to explain? So I wanted to keep thrust on this point that, see, I already had intervals, I had already merged them. Now I got an interval which was actually lying somewhere between my older previous intervals. See, just immediate previous interval should have been this interval. So whichever interval I compare, it should be in such a way, I am making comparisons in such a way that I don't have to care about my older intervals. You getting my point? So that is only possible if I can have my start indexes of the intervals in sorted order. The reason is, when I got an interval like this, right, it is not in sorted order clearly because I'm getting 3 in the end, which is not the highest of these starting values. So when I got 3 in the end, I had to go to my previous intervals, not just the immediate previous but the intervals that were before it until I got my first interval, because there was a possibility that 3 as starting index might overlap with any other interval, right? So to avoid this comparison through all the intervals that I have merged, what can we do is we should typically sort intervals. We should sort intervals in the increasing order of start points. Got it? Okay. So when I now just forget about it. So this was your original test case, and after sorting also you will get the same. So in this case we can say your task of sorting was irrelevant because it was already in sorted order. But since I already explained to you why we need to sort, that was the reason. So for this test case, this step we can assume that has been already done. Now next step is what? So my next step is where I am introducing you to with the stacks. How stacks is helping me? Let's have a look here. See, let me write it here only. So what am I doing with stacks? Now a simple thing, the simple comparison that I just iterated right in front of you, we will be doing it using stacks. Why stacks? See, because using stack, I told you whichever interval I am comparing, I am trying to compare that interval with the just previous immediate interval, right? So that I don't have to go down the lane to check what all intervals were merged. I'm just comparing it with the last previously written interval or computed interval. So the best the data structure which can give me the last inserted value in the least time complexity, in big of one time complexity, is what? Stack. Why? Because stacks are designed to store elements such that the element which was recently inserted into stack, right, I will get that value in O1 of time complexity. So the last interval which I inserted will be present at the top of stack. So I can easily make my comparison with the incoming interval with the interval that is present at the top of my stack. Okay, so now let's see how are we going to do these insertions. So here you have a stack. We are creating a stack. Okay, fine. So this stack initially will have 1 and 3. Fine. Okay, the next is this. I will be comparing 2, 4 with the top of my stack. So I have 2, 4 which I want to insert, but I will do some comparisons. First comparison will be the start of this interval. Is this greater than the end of my interval that is present at the top of the stack? We can clearly see that the start of current, you can write this start of current, is less than this start of top. Okay, then it means that this interval can clearly be merged with this interval. If it can be merged, okay, if it can be merged, what should be the ending value? See, this interval starts from 1 and ends in 3, but this interval starts at 2 and ends in 4. So its ending is actually greater than the ending of this interval. So clearly the one which is greater as the end point, I should consider that. So I will do what? I will simply update the end and I will check what is the, see, in this I will keep a track of what is present at the top of my stack. So top of my stack will have start. If I am merging it, if I am finding this condition to be true, if start of current is less than start of my top, then that means I am merging it. Now when I am merging it, what I am doing, I am keeping the start same, but I am updating my end to be max of this current dot end value and max of top dot end value, right? So this is what I'm doing. So which one will be the maximum, that will be updated in this particular interval. So this interval now will become what? This interval will become 4, 1 to 4. You got it? Okay, now this has been merged here. So go to the next iteration, which is 6, 8. Now I have to compare 6 and 8. Do the same comparison. Check the start of this interval with the end of this interval. So start of this interval, you go to the, either you can write this in the else condition and this in the if condition, that if if start of, wait, what if I get my start of current greater than the start of my top. So current, right now my current is 6 and my top is 1, start values of both I am telling. So right now the top current's start value, this is my current, and current start value 6 is greater than the end value, sorry, not start, I'll just make a correction here, end of my top. Okay, so these things are little, might feel like you're not, sometimes you're getting confused, but trust me, this is really very easy once you understand the flow of this question. When you try to do it on your own, right, this is very easy. You just need to understand what I'm doing here, and then you should try yourself using one example first before coding. Try to do a dry run on an example, then very easy to code. Okay, so I'm comparing it with the end of my top value. Top value's end is 4 and the current's value start is 6. It is greater than 4. Can it be merged? Clearly not, because one interval which is already in my stack is starting at 1 and ending at 4, and another interval is starting at 6 and we don't care what it ends with. I am going to insert it as it is into my stack. So st.push the current interval. Okay, in the else case you were doing that task, right? In the else case you were doing the task, that is you were comparing and then you were, else you are merging. Okay, and how are we merging, I already told you. So while we will code, you will understand it better. Okay, so next interval will be 6 8, fine. Now my next interval that I'm comparing is 9 to 10. So currently my interval that I'm comparing is 9 and 10. So start of my current is 9 and end of my top, this is my top, its end is 8 and its start is 9. Is 9, let's check, is 9 start of current, 9 greater than the end of top? Yes, 9 is greater than 8. So do nothing, just push that interval as it is into your stack. And you are done with the iterations. You are done with all the intervals along with the merging, whichever needed. Now what? Now you will simply do stack.pop and return your answers. One thing here is, in the end of our code, we will be creating one extra stack, because our question has not explicitly written this thing that they want the intervals in the ascending order of the start values. So if you try to return directly from st.pop, you will end up getting answer in reverse order. So to get it in the right order, I will create one more stack so that their orders can be reversed, and when I do a pop, I will get the exact order that I need. Okay, now things that I'm going to use in code, I just want to bring to your notice that while we were solving questions previously, I remember from our SD sheet itself, we have solved problems where we have made use of comparators. So I'm sure if you have gone through those videos, you are well aware of how comparators work. So why I'm bringing this point, the reason is, in your question you are given intervals as a 2D array, right? And I want to sort actually the intervals on the basis of the start values, right? So in Java, since I will be coding in Java, so we have a functionality to sort the array of integers, right? But I want to sort a 2D array on the basis of the first values of out of the two values, right? So what I'm going to do, first of all, I will I will take a class pair, okay, and class pair will have two values, start and end, fine. So in this class, from this class pair, what I'll do, I'll create an array of pair. Okay, I'll create an array of pair and I will iterate over intervals. From intervals, I will actually insert into this array these intervals as start and end values, right? A new pair which contains start and end value. So that you can iterate over an array of pairs. So pair is the object. Basically, I will be creating an array of objects. Okay, so when we want to sort an array of object, right, We know how to sort an array of integers, that is by using arrays.sort as my method in Java. But when I have an object which I have explicitly defined also, which is containing two values, start and end, which are typically intervals, first value and the second value, right? Then what I'm going to do, I will make use of comparator class, through which I will be sorting this array of pairs on the basis of the start values, right? So this task we will be handling like this. I have already given you enough information about how we are doing and why we are doing, but if you still don't understand and want to get into its depth, then you might have to work a little bit on understanding how comparators work, or a little bit about lambda functions, because we will not be taking it separately in this question. This is the expectation that at least you know, since we have come so far, so you should be aware of how comparators work and why and how we are using it while sorting an array of objects based on some value, be it start or be it end. Okay, fine. So let me just check if you guys have any doubts so far. Let me just okay, I think that's okay. So let's have a look at our code now. We will directly dive into the code. So in my code, I'll start with creating a class of pair. Just give me a second. I'll just hold my keyboard. Okay. Fine. So let's create a class pair which is containing, code is going to be a little bit lengthy. The reason I'm coding everything in front of you, so that you can understand whatever we discussed exactly where and how we are implementing it. So this is the class pair in which I am defining int start, int end, then I am making a constructor public pair taking two values, int start, int end. Okay, let's initialize them. This dot start equal start and this dot end equal end, right? That is fine. Okay, so let's move to the function, the actual function. Now what? I told you I'm going to create a new array of type pair. So let me define n as size of intervals dot length. Okay, fine. The next thing is I'm going to create an array of pairs. So let's take pair of pair arr new pair. Fine. Okay, of length n, right? Okay, next thing, let's fill up the array. We created this array of pairs, let's fill that. So for int I equal to 0, I is less than n, I plus plus, iterating over your intervals array, arr of I is going to be new pair of, why is it new pair of intervals of I0, that will be your start value, and intervals of I1, which will be your end value, right? Okay, I1, which is going to be your end value. Now what? Next thing will be, I am going to create a stack. Stack will be of type pair, because in stack I want both start and end values. So we created pair for that purpose only. Let's create a stack of pair, st new stack. Okay, fine. Let me just check if you guys are okay. Fine. So new stack like this. I've created a new stack. Now I want to sort my arrays.sort. I want to sort what? I want to sort this array of pair that I created, right? Arrays.sort. What will I insert? I want to sort this array, but this array is not of integer type, so that I can directly use arrays.sort. This is of an object type, and over that object I want to sort on the basis of the first value of that object, which is start values of that pair, right? So I'll use my comparator function. I will implement it. So here I have given one argument ARR, and the next argument will be my new comparator. I'm implementing comparator method. So comparator is comparing the pair. So this is the type that you have to give in here. That is, the type will be pair, correct? And then what? Then nothing. You are now implementing public. You're calling the function public int compare. You're making a function public int compare, which is taking two values, two pairs, pair A, pair B, and you have to sort on the basis of first values of both the pairs, which is the start values, right? So I will return A dot start, because you want to sort in the ascending order of these start values of these pairs. So A dot start minus B dot start. That is what I want to return. Minus B dot start. Fine. So this is your comparator method that we have written here. Now next thing is what? Now next thing is for, now let's do our comparison, and based on the comparisons we will be either merging or we will be directly pushing into the stack. Now let's iterate over. For pair P, let's say pair P belonging to what? ARR, right? ARR. Okay, fine. Now what if I told you, okay, so since right now your stack, this is the stack that we created, this ST is empty right now. This ST is empty right now. So I will check if ST dot is empty. Okay, then you just directly push the value. So ST dot push this P and continue, right? That means you move back to the first line of your code and do not execute the further lines, and then start over again for the next pair of your array. Fine. Now what? Now the next thing that we are doing is we are comparing while your sorry, not while, if my P dot, what is your current, this is your current pair, right? So I'm comparing current pair with the pair that is present at the top of my stack. So let me store that top pair using name top. So pair top is equal to st dot peak, that is the peak value. That's how you give it, right? Now what? Now I'm checking if P dot start is greater than my top values end, right? Then in that case you are simply going and pushing into your stack. St dot push that interval, because no merging is going to take place, and the current interval that you're checking is the interval with name P, right? So I directly push. And in the else case is where you should be merging and also checking what should be the end value of that particular interval. So you must have some interval already present in your stack. Now what is the case that you found a start of the P pair which lies between the interval that is already present in your stack. So what we are doing, we want to merge it. So I will simply update the current what is present in your stack. First I will remove it, then I will push the top, then I will push this pair, probably not this pair, I will push back this top pair with an updated end value. What will be the updated end value of this top? It must have its end value also, but what if the pair that we are inserting has a greater end value? So it should be updated with that. So that's what I'm going to do. First I am removing what is currently present in my stack, because I want to update the interval, right? So I'll update it like this. Then top you have already stored as pair top, which is the value, which is the pair you just removed from the stack. So you already have it saved here in top. So top dot end, I am going to update it with math dot max of top dot end and P dot end, right? P dot end. That's how I'm updating my top value. And then st dot push this top, right? So you have updated it. Now next thing is what? You come out of this else, you come out of this for loop. Now finally you have to return your answer. For that I am creating a new stack of pair, because I want to return in the increasing order only. Because even if you can check it on your own, if you try to return the answer without creating this array directly, it will give you reversed answers. So that's what I checked myself. That is why I'm creating it right in front of you. Okay. So also before I do that, let me do it. Stack of pair new new stack is equal to new stack, right? Okay. While your st is not empty, what you are doing, you are just pushing nst dot push st dot pop, right? Okay, fine. Now next what? Let's do the same thing from nst. So while, let's see, while nst is not empty, okay, while your nst is not empty, then let me take a pair which will be the top pair t is nst dot pop. You're removing the topmost value, and finally actually I want to insert it into a 2D array. This is how you're returning it. So I'm creating a 2D array. Int res equal to new int, what is the length will be the size of stack, which is, you can write here, nst dot size, right? And the columns will be 2 because you have only 2 things to give for each array, that is start and end value. So that's how I have created this resultant array. So while your nst is not empty, you check what is the top value and insert. Top value has 2 things, one is your start and one is your end. So start should go in the first one and end should go in the second value of the second index of the array of res, right? And res of, let me take int i equals 0. So rest of i0 will be, rest of i0 will be t dot start, and rest of i1 will be t dot end, right? And you're doing i plus plus. Fine. Finally you return res. So let's check if we get any error. It's a lengthy code, so I'm expecting any error will come. Let's see. I just hope it doesn't. It's taking a lot of time. We got an error. So which is 72, line number 72. Let me check. Top, why top dot end is okay. This is capital M math dot max. Let's check. Okay, we got the right answer. It should actually submit as well. That is all about today's problem. I hope you got this problem. So obviously we are taking an extra space, we are taking time complexity for sorting, right? Then we are doing this task when we are filling up the values in our stack, we are taking maximum O of n time only, okay? But since we are doing this sorting process, so it is taking log n of time complexity, is total n log n is the time complexity that we are taking, and obviously we are taking extra space as well, okay? So that was all about this problem. Fine, then you can ask if you have any doubts, else we are done for today. Let me just check if you guys have any doubts. Let me check. Okay guys, if you have any doubts, you can write in the chat. I'll take it up, otherwise we will wrap it up. Okay. So no doubts. Okay, then if you have no doubts, we will wrap it up. See you all in the next lecture. try to do it yourself, else you can always come back to the video and understand it. Okay then, see you all in the next lecture. Bye bye, take care.